Right, hello everyone, welcome back to another one of my railway vlogs. I haven't done one of these for a while because I've been quite busy. Being the summer months, we're either down in allotment, which some people might have seen my allotment vlogs, or we're out in the motorhome, so I don't get a lot of time working the railway. But I've done a few little bits which I'm going to show you in a minute, and I've got a bit of time lately just to try a little projects out. Like I say, normally because it's daylight, I'm normally out and about, so I don't get time. But anyway, what I'm going to be showing you today is some people have been mentioning about they're trying to do the turnout setup and getting the feedback working, so you have a feedback back to JMRI to tell JMRI that the turnouts move from one way or the other, which isn't too hard to set up. But then you also I wanted an external switch, say on a mimic panel, so you can push the switch and then that can make the turnout move as well, but also update JMRI to say that the turnout's moved. And there is a bit of an issue with it, which I've had, where the turnouts would just do their own thing, or the because of the feedback loops in there, it'd go to a closed position. You'd ask it to go to closed position, and it'd go to closed, and then it'd go back to throw, and then it wouldn't stay in a closed position. And I know other people online have had this issue as well, and I've managed to get it working. And the way I do it, I'll show you in this couple of minutes, is probably not the most easiest way of doing it. There's probably other people out there doing it other ways, and if you've got a better way of doing it, obviously comment below, go on my blog, because this will all be on the blog, and comment on that as well, because I'm quite happy to learn more myself. It's not that easy with CMI, with the amount of information out there on the internet. Anyway, so without any more, what I do first is I'll show you I'll show you it working, and then I'll go through and show you the Arduino code and the JMRI setup, so you can see what I'm trying to do. Now just grab the camera. Right, so what I'll do now is I'll show you a demonstration of what I'm doing. I've got a servo set up here. You can see it's just focused in. The camera will probably go in and out of focus because it's on autofocus. But the servo's set up here, and as it operates, it'll make this micro switch. And this micro switch is connected to the Arduino on pin 6, I believe. And it's ground to 6, and so it just gives an input to the Arduino, which then sends it as a bit number back to JMRI as a feedback to say what position this servo's in. Imagine this servo is connected to imagine it's annoying me, it keeps going out of focus. Imagine if that's connected to the turnout, then you'll have control. And I've also got a push button here, which is connected to the Arduino, which if I operate the push button, will operate the turnout. And so just for JMRI purposes, on the left hand side of the screen there, you can see up here I've set up a turnout, which is connected to address 1001, and I've got it in the throw position. And if I click this, you'll see this turnout, this servo over here move. I'll just bring this up here closer. So if I click on that, oh, that was no good bringing that over, was it? Bring it back. So there you go. So if we click that, you can see the servo over here moving. And so down here, I've got a sensor, which is this micro switch here, which is again address 1001 because it's a sensor input. I've given it a name of S1, so this is the sensor for that micro switch, and it's showing active. Now, if you keep an eye on this now, when I'm operating the throw and close of the turnout, you see it goes inactive when I've operated it, and it's gone active when I'm operating. Change it the other way. So you can see now I've got a feedback now going into JMRI for this micro switch. And over here, just to make an add-on, I've got, I don't know what's this screen behind, I'm not doing that bit yet. I've got a turnout set up on a layout, which again, if I operate it, you can see the turnout change on the picture, and the micro switch, the servo actually moved, and bring it back, it goes back again, try it again, and you see this gone inactive, bring it back, that goes active, and the throw over here is operating each time either. So everything's working in sync with JMRI. Now the problem, that was one problem I had because it never used to do the feedback properly. But then the next problem comes when I want to get a switch like this on a mimic panel, because I want to do some of my own controller trains. I don't want it done through JMRI, I'm decided to do my own thing. And so I want to push this button to operate this turnout. And so what happens now is when I push this button, which I'll do in 2 seconds, you'll see this over here. This is connected to this switch sensor address 1002. And it's inactive at the moment. So when I push the button, this will go active. And when this goes active, you'll see everything else around here change. So here you go, I push the button. You see, it's gone active. This has gone inactive. It's gone to closed. And that's in the closed position. And the servo's moved over. So I'll do that a couple of times so you can see it all working. Push it again. There you go. So that's a couple of times what we, and it's just a push button that I'm using here. And the beauty of this as well is if I click the push button, so I've made the turnout go over to a closed position, but then I want to go to JMRI and change it here, I can click on this and it'll still bring the servo or the turnout back to the throw position. Now I can come back to my button and I can close it again. And I can do that as many times in different ways without it going out of sync. So that is the main setup. And so now what I'll do is I'll quickly go through all the code. All of this hopefully will be on my blog, and if you don't follow the video through, go to my blog, go through that. If you find any mistakes on my blog, which other people have found, just let me know. I'll go over it and rearrange it, because sometimes writing this stuff up is not as easy as demonstrating it on a video, and I make a lot of mistakes on the blog. But going through the code, so for the Arduino code, starting at the top, right, we've got the basic include libraries, which I've used for all the others. The only difference here is I'm using servo.h, because I'm not using the PCA card. Anyone remember the PCA card which I'll show you a picture of now. Hang on. Anyone remember this card that I used? I might go back to using it, but at the moment, for simplicity, I'm just going to use the servo.h library because it makes it easier for writing it up, and also carrying the gear around I've got. We have a setup for the CMRI, which is basic like normal. The only difference is I've given it a different label. I think that used to be called buzz on the other ones. I've called it a bus address pin because that's what the pin is connected to, pin 2, and I've put that into there. And then we've got bus in there. But most of that is all the same as we've done before. Turnout setup is the same. I've given the bit that I'm reading from CMRI a name called CMRI T1 bit, and I've set up a servo T-out1, which is what I did before when I was doing the servos. If you look back at my other videos or go to my blog, you'll see the same thing. For the feedback switch, this is the add-on bits. This is the micro switch. Yeah, so it's just a basic reading of a switch. So we have it's connected to pin 7 switch and ground. So it's just a basic normal switch. So pin 7 and ground, and you've got feedback switch is the name that I've given the pin 7. And then we have to be able to store the reading. When we read this switch, we have to store it somewhere. So I'm storing it in a variable called feedback state, which I've set to 0 at the beginning, which I'll go over a bit about that in a minute as well, problem with them. And then for the actual push button, I'm actually using the same library or same example as the debounce one, which if you go to File, Examples, Digital, for the examples that you come with Arduino IDE, and go to debounce, I'm pretty much following that, just change a few wording. So for starters, we're connected to pin 6 and ground for my push button, and I've just given it a button of control switch because it is a switch that's going to control the servo. We have to store the state of that switch into a variable, so that's a control switch state, but we also have to have a last control state because it's a push button, it's not a toggle button. We have to know what state the button was in each time it goes through. So this is part of that debounce side of the program. So that's set to low at the moment, and then we're going to toggle. If we was doing a debounce program in Arduino, they toggled an LED and they called it LED that they toggled. Well, I'm going to toggle a variable called control, so it's either going to be 0 or 1, and that's what we're going to send back to JMRI. That's the bit we're going to be sending back. So it's 0 or 1, and that's going to toggle each time you push the button. And then we have a debounce time, last debounce time which is set to 0, which we record the time, how long it's been since you pushed the button, and the debounce delay is the time we're going to delay, so we hopefully miss out any noise or false feeds from the button. And I'm not going to go through every single little bit of the part of this program because it is in examples, and it's a bit a head thing to get your head around it in the first place. Right, setup, pin mode. We're doing the feedback for the micro switch is an input, and I've given it an input, but I'm using the pull up. So this is an internal resistor built into Arduino that you can use rather than adding loads more electronics outside of Arduino. If you just put this input pull up in, then you can literally just connect up 2 wires to the Arduino and away you go. You haven't got to add any extras to your circuitry outside. And the control switch, my push button, same thing, it's an input pull up. Bus stop begin, same as what we've done before. The T1 out, which is my servo, is attached to pin 8 for the control side of it. And I'm writing to it straight away at the beginning 10, which just moves it into position at the start up of my Arduino. You can do what you like on this when you set up it with your turnout, because you want to maybe set up your turnouts either in closed or throw positions when you first start up your railway, and it's what you can do in your setup. So for the loop, we start the CMRI process as I've done previously. We're going to read the bit 0 coming in, which is the bit coming in from JMRI. This is the turnout bit. So it's address 100, and that's this bit we're pushing through. Yeah, so it's reading that bit coming through, and it's going to store it into the T1 bit that I've said about. And then it's going to say two if functions. One, if turnout bit is equal to 0, we're going to change our turnout to position 0. If it's equal to 1, we're going to change it back to position 10, which is written at the beginning up here, if you remember. So it's just going to change the turnout from one point of the servo, from one position to the other position, depending whether the bit was 0 or the bit was 1. Quite simple, that part. And in down here, we're going to call two functions. Rather than putting it all in a loop, I've just pushed it out into functions to make it a bit easier. So for this one, we're going to read the micro switch. No, sorry, that's the read switch. We'll skip this one. We'll go for the read micro switch first. It's the easiest bit. So we're going to read the micro switch that's attached to the servo. That's that little black micro switch I showed you. The feedback that shows you what the turnout's done. So we go down here to read micro switch, which is down here. So it's void read micro switch, void read feedback switch function, and all we're going to do is the digital read of the actual switch, and we're going to store it into this feedback part, which the switch will either be 1 or 0 depending whether it's been operated. And then we're just going to send that back to JMRI using CMRI under set bit. So this sends it back to JMRI rather than reading it into JMRI. So we're going to send it back. We're sending it back on address 0, which will be 1001 on JMRI. Remember, it's always one head, and we're sending it whatever the switch state was. And this is what goes into 1001, this one here, which is your little black feedback micro switch. Right, so when it's done that, or vice versa, you can move these around, doesn't really matter. And then we're going to read the actual switch. This is the little push button switch. So we're reading the switch. It's a bit more in depth because it's like takes the D bounce. It reads the actual switch, which we're reading here, to see whether it's been operated. So it'll either be a 0 or 1 in here. It's going to say that if the reading we've taken in here is not equal to the last control state, which means it's probably not operated, we're going to take a timestamp of the program that's running. That's what the time is actually at the moment within the program. We're then going to take the time, and we're going to take away the last D bounce, which was 50, and we're going to say if it's, I think, no, that's to take away the time that was up here, sorry, and if it's less, if that turns out to be less than the D bounce delay, which was 50, then we can go through to the next part of the reading. So we've given it time for any D bounce, any problems with the switch to go through, so that we can go through to actually see whether the switch has been operated. So any small little bounce of the switch wouldn't get through to this side in the first place. Yeah. So that kills out any noise within the switch system. So then we say that if the reading, which came through up here still, and it's been over the 50 milliseconds, is not equal to the last control state, so it's still changed. Yeah. So we know the button's now been operated. Then we take the last control stamp and we store the reading into it for the next time it goes through. So that's when we change this part of the program. Then we say that if the last control stamp is equal to high, yeah, which means that the button is being pushed and it's held in, we're going to toggle our control. Remember I said control set to, I think it's set to 0, yeah, it's set to low at the beginning of the program. So down here we're now going to toggle that control, so it now be equal to 1. And if we push it again, it go back to 0. So it's going to toggle it from 0 to 1 every time the button is pushed. And then we're going to send that button to JMRI.setBit, and we're going to put it on address 1, which will be 1002 on JMRI, and we're going to send it the control, which is either a 1 or 0, depending where the button, when the button's been pushed, it toggles it. And that's it. Bit of a head one. Probably, I don't know whether I explained that very well. If you don't understand it, you can copy and paste this, but you can go for the debounce examples that are in JMRI, and there's a lot out there on the internet. Now, one thing I would like to mention, I haven't done this on more than one servo, so to do 2 servos, you'll have to start making up debounces for 2 buttons and stuff. And there is some out there, programs out there, which I haven't done for a while, and I've got to look up, where you can do multiple buttons through one function, rather than you have to keep writing all this out. So I'll have to look that up at some point, whenever I get around to building it that way, because a lot of this is just theory. Right, so that's the Arduino side of it. Right, so the JMRI side. The JMRI side is not as bad, it's quite easy. So we set up a turnout. Everyone should know how to set up a turnout by now if you follow my last ones. It's got CT1001 for the address. If I was going to go through and show you it, it'd be 1001 in there. You give it whatever name you like. You click create. We're using a 1-bit for this, and we're using steady state, not the pulse. I'm not going to do that because I don't want it. Oh, it did it anyway. Delete that. And so that sets up your main turnout. And then the only other thing, then, you need to set up a feedback within the turnout, but you can't do that until you set up your sensors in the first place. So if you come down into sensors and click add a sensor, again, CMRI, give it the address 1001 or 1002, depending on what one you're setting up. Give it the name. This was for this switch. You click create, and that will create it. And that's basically it for the sensor. I'll just make sure that I haven't missed anything now. I'll just put a 3 in there and give that a different name so it sets up another sensor. Click create, yeah, and that's it. So there you go. That was the other one I've just added, which I'll delete. And so that's how I set up both of these sensors. So that's quite simple to set up. And then you can go back up to here to your turnout, click on edit, go to your feedback, and then you drop down the feedback. You'll probably have yours in direct. Click on one sensor to bring up the one sensor light. These will come to life then. Click on the first one down and select it to S1, which is the micro switch sensor 1001. I've given it a name of S1. Whatever you gave your name in here will come up here. Give it S1 because that's the feedback from the micro switch. I've not touched any of this. I don't really need it, and it's switched to off anyway, so that's not used at all. The only other thing might have used lock. I'm not used speed, usage, properties. No, that's it. So for that, that's everything. So click OK on that. So that's that set up. For the switch, just going over that, I'll just go over the edit on the switch. I did add something into here actually, just to show you another debounce. There's a debounce in here as well. It was, I haven't done it in this program, it's on my laptop. See, as I was having problems with my laptop, when I did it on my laptop, the switch was triggering 2 or 3 times when I was pushing the button, even though I got the debounce in the Arduino. So I added 3 into here, and 3 into here, which is 3 milliseconds delay before it takes any action on any of the readings. So it takes away even more of the problems with the noise and stuff on the switch. I apply that anyway, and that's a big issue with push button switches and not toggle switches, is that you get a lot of sometimes noise and bad activations. So with both the sensors now set up, the turnout set up, and the turnout's also now connected to this one here, S1, which is a micro switch for feedback to the turnout. Everything for feedback wise should work fine. The only thing I will say, which I have had problems with, and this goes back to the Arduino code, if you have problems where it keeps toggling backwards and forwards, the thing, you have to change. What did I change? It's the way the micro switches sends a 0 and 1 in, and whether the turnout is in a throw or closed position. So I actually changed this. I started my program up with this being at 0, and that was where the micro switch wasn't made, but I'm probably sending the 1 back to say it was made. So I had to change that to 10 to say that the turnout is in a different position. Either that, or you might have to change on the feedback side of it, just do an inverse sign on that and put an exclamation mark there, which will do it, because it needs to be inverse to what you're doing. The other way you can do this, and I'm probably waffling, you probably don't understand it, hopefully you do. If you are getting it bouncing backwards and forwards, it's not the best way of bringing all this up. You can click on this one here, this is the feedback sensor, you can click this little tab there where it says invert, and then that will solve the problem. And actually it's doing it now. See, a good example, I'll show you it now actually doing it. See, look, now I've got the micro switch over here. Now I've clicked this invert. When I click this close button, if you watch what happens with the servo now, you see it's always going to go to close it, and then it brings it back again, because JMRI, I think it's, remember reading something about it, it needs to be in a certain state, the feedback needs to be in the right state for the right closed or throw position up here. So if, I can't remember if it was a 0 or 1, say this was set to 1, this had to be set to throw, not closed. So if you're getting that problem, just click that button and then it'll work. Right, so just showing you that because that's one of the problems I had. It took me a while to figure out why that was doing that. So anyway, so now we're set up with the feedback and we're set up with the push button that's on here. And over here, you've probably done this before, you click on the right hand little button up here, hold the shift button down and left click, which will put a turnout on the screen, right click on that, click on details and then drop that down to set it. Mine ain't going to come up on this because I've already done it. Yeah, I'll show you the one that's set up actually. If I right click on that, click edit, you can drop down that and you select T1, which is the name for my turnout up here. So that then that turnout there is connected to all of this to control everything. I'll just delete that one. I think I can delete it. Yeah. Don't know why it's gone small all of a sudden. Anyway, so that sets up that. That's quite an easy setup. So then the only thing you've got left to do is to set up the switch. What happens when I push this switch? Because it's really hard to do it in the Arduino code. It's going to get too complicated, and luckily Arduino, JMRI, made it a lot easier. And what I've done is I've set up a route. So if you go over to, I can't bring this out for some reason. Yeah, look, so I'll try and drag it out, it won't come out. But if you go in your menus on the left, you'll have one down here saying routes. Yeah, which I can't show you, but I'm pretty sure it's called routes. Just bring this up. I have to do it for this. Tables. You go tables and routes. There you go. And that'll bring up this window, routes. And what we're going to do is we're going to add a route that operates when this sensor, which is the switch, has been operated or activated. What I'll do is maximise this. I'll click edit on this one rather than go through. So if you click add routes, and you get this window, edit. This is the same one. So I've given it a name, turnout 1, which you can call it whatever you like. I'm using the CT1001 turnout. This is what we're going to operate. So I've clicked the little tick button here to say we're going to include that turnout into this route. And what we're going to do is we're going to set it to toggle. So every time this route's called upon, it's going to toggle that turnout from either being closed or throw, depending on what state it is, it goes to the opposite state. And so this one you're not worried about sensors. We're not including any more sensors. But we are going to, down here, we're going to say what is going to trigger this route. And what's going to trigger it is our switch push button. And we're going to say that every time it's on change, so every time that state changes from a 1 to 0 or 0 to a 1, we're going to trigger this route. So as soon as that button's pushed, it sends a different bit through to JMRI, which will trigger this route. And it will then toggle that, that turnout, which will change the servo. And that's basically it. There's nothing else in here, no delays or anything I've done in here. And what happened then is when you push the button with the switch, it sets off this route. This route will then change out this turnover from throw to closed, and by doing that the servo will change, and when the servo changes it will then send the feedback through this micro switch to change this from active to inactive, and then all this would also show on the display up here. And that's it. Hopefully that all made some sort of sense. Like I say, I'm putting this on my blog, so it'll all be on there as well. You can have a look at there in a bit more slow time, go through it, and if you've got any problems, obviously put some comments on my blog or on YouTube, and I'll try and go through it and see if I can figure out what's going wrong if you've got any problems. Hopefully you don't get any problems. And I haven't done this on more than one servo, so that's the next thing. And I haven't got signals on this yet. I don't know where I'm going to do signals on JMRI. I'm tempted to do signals on a separate Arduino completely, nothing to do with a JMRI. But that's about it really, I think, for this. So what I'll do then is I'll leave you with that. Just show it working one more time so you can see that it's still up and running. If I push my little button, there you go, my servo's changing. It's great when it works. And then again up here and over here. So it all works perfect. What I'll do now is I'll do a little quick show around what I've been doing around my railway for some people that have been watching it. I haven't done a lot, mainly it's been model making and connecting up some wires. Like I say, I haven't had a lot of time. So I'll show you around that now. Right, so most of the railway, like I say, I haven't done a lot on the track work. I've got a load of track turned up now though. I've got another box of track which is turned up from Hatton's. It took about a month for it to turn up because I've been low on stock. Mostly it's been model making, just bits and pieces I can do late in the evenings when I've got back from work or something, or back from my plot. A lot of it's been, let's move this out of the way, let's turn that wrong. A lot of it's been doing the ballasting, which takes a bit of time, so I've been slowly ballasting stuff in, and I've been winding up the tracks so that these trains can run up and down this part. I've built a platform, which isn't the perfect flat platform that you would normally get. I'm not great at the model side of it, I like the electronics, and I'm slowly building up my second platform, which is going to have the main station here, and then up the back here, when I get around to doing it, that's going to be raised, that's going to go up. And as it goes up, the train will go up above here and over a road over the back there. A lot still to go, really, but that's mainly what I've been doing. And I've been doing one of the turnouts. So that turnout there is actually got a servo underneath it now, and I'll show you that under here. If it goes too dark, no, it's gonna be too dark. But I'll show you that at some point how I connected up that turnout, because I've done it really simple, just gluing bits of cardboard around it and gluing it underneath. There's no cost really much involved compared to what I've seen a lot of people buying these devices to connect the servo up. But because it's still prototype, still working on it, and I've still got to get the feedback set up, I haven't done a video on that yet. And then the other thing I've done is I've built one of these little stops at the end, buffer stops, which I've connected up. I don't know whether power's on this. Hang a minute. Yeah, I've connected up a little LED. I don't know if you can see that there. And this is surface mounted LEDs you can buy on eBay, already pre-wired. It's got little wires already attached. No way I'm going to be able to solder them with my shaky hands and eyes. So you can buy these already soldered like that, drop it through the bottom, and then connect it up to your 5 volts. Brilliant really for the price of them. So yeah, that's basically it. That's all I've been doing. There's no more on the other side been done yet. The other side's actually a bit of a mess, where most of my stuff gets done for working. So that's it for now. Hopefully you enjoyed it. Please give us a subscribe, because it helps me build up my YouTube channel and it keeps me doing the stuff that I'm doing. Without enough subscribers, I'll probably end up not carrying on for much longer. So please give me a thumbs up and subscribe, because that really helps on the building of the channel. Anyone got any problems, like I say, go over to my blog, and hopefully it'll all be up and running on there soon.